Now we are going to discuss about the topic basic concepts of thermodynamics. Okay, let us learn through some examples. First of all, if we rub our hands, what happens? Right, the palm gets warm, right? So we rubbing our palms, it produces some heat. So the some amount of work by rubbing our hands, it converted into the heat energy, right? So some amount of work is converted into the heat energy. Next, now we switch on the fire. The metal rod is placed, the one end of the metal rod is placed at the fire. What happens? Right, the metal rod is heated at one end, but the heat is flow through the another end also. We feel heat at another end. Why? Because the heat is conducted, that is the heat is transferred from one end to the another end. So there is a motion of heat. That is thermodynamics. Thermodynamics means, it's a Greek word, it's a study of motion of heat. So thermodynamics is a branch of science. It's to study the motion of heat and also the how the energy transforms from one form into the another form. Okay, let us dive further into the topic. Thermo means heat. Dynamics means motion. Thermodynamics is the study of motion of heat. It is a branch of science to study the flow of heat, and also it describes how thermal energy is converted from one form into the another form and how it affects the matter. In the introduction section, we saw two examples, right? First one, if we rub our palms, it produces heat. That's because some amount of work is converted into heat. And the second example, the metal rod, when heated, it transfers energy from one end to the other end, right? Both examples explain clearly about the thermodynamics. Next, laws of thermodynamics. It has 4 laws. They are zeroth law, first law, second law and third law. Let us see one by one. First, zeroth law of thermodynamics. It states that if two bodies are each in thermal equilibrium with some third body, the first two bodies are also in thermal equilibrium with each other. Let us learn through some examples. Now, consider we take a cup of coffee as A with a temperature of 50 degrees Celsius, and we take a cold coffee as B with the temperature of 10 degrees Celsius. Now, both the cups were placed in a room of a temperature 30 degrees Celsius. What do you think it will happen after some time? What happens is A and C attain thermal equilibrium. Similarly, B and C attain thermal equilibrium. The zeroth law states that if each of the two bodies are in thermal equilibrium with the third body, then they will become thermal equilibrium with each other. That is, here A and B becomes thermal equilibrium with each other. Next, first law of thermodynamics. The energy can neither be created nor destroyed, but transfer from one form into the another form. Like the heat energy is converted into the mechanical, electrical and chemical energy and so on. The net change in the internal energy of the system is equal to heat added to the system minus work done by the system. Let us consider an example of boy taking a health drink. The energy flowing into the boy is taken as Q. If a boy takes an energy drink, then he gains Q amount of energy from it. That means Q amount of energy is entering in his body. So he has gained Q amount of energy to do work, and right now he is having the internal energy of U1. Now the boy is playing football and spends some work amount of energy by the work. After playing, his internal energy becomes U2. Now the inlet energy, that is Q, plus the initial internal energy, that is after taking Q amount of energy, minus of work done, that is equal to final internal energy. It can be mathematically written as U2 is equal to Q plus U1 minus W. Then U2 minus U1, that is du, change in internal energy, that is equal to Q minus W. Therefore, the change in internal energy is equal to the amount of energy taken minus how much amount of work done by the system. Next, second law of thermodynamics. A process which needs no work done. Earlier we have seen an example where the hot coffee is automatically cooled down to room temperature without any external work. Likewise, here also we can see that the heat always transfers from hot region into cold region without any external work. But it is not possible to transfer the heat from cold region to hot region without any external work, and the same is explained by Clausius. He states that it is impossible to construct a device that would operate in a cycle with extract from lower temperature and supplies to higher temperature without any external agency. Next, Kelvin-Planck statement states that it is impossible to construct a device that operates in a cycle which receives heat from a single source and convert the entire amount of heat into work. Practically, we cannot convert all the energy into work. There will be a little or minor losses in it. Next, third law of thermodynamics. The value of entropy of a completely pure crystalline substance is 0 at absolute zero temperature. Before that, we see about entropy. Entropy means it's a measure of randomness of the molecules. Let us consider a system containing a randomly moving molecules. If we decrease the temperature of the system, then the molecules' movement will decrease along with the decrease in kinetic energy. If we further increase the temperature, then the molecules' movement and kinetic energy decreases further. Continuously, the temperature is decreased till 0 Kelvin or minus 273.5 degrees Celsius, then the molecule does not move, becomes static with zero kinetic energy. Since there is not any movement in molecules, that is, entropy is 0. Now, we see some applications of thermodynamics in our day-to-day life. First, steam engine, where the heat energy is converted into mechanical energy. Next, refrigerator, where it removes heat from region and deposit into another region. Next, thermal power plant, where the heat energy is converted into electrical energy. And all the fuel engines like bike, car, planes, etc., where the chemical energy of the fuel is converted into thermal by combustion. Finally, the air conditioner in our home, where the AC collects the warm air from the surrounding and converts it into cool air with the help of cooling gas. So far we discussed about the basic concepts of thermodynamics. What are the laws of thermodynamics? There is 4 laws of thermodynamics and its application. Thank you for your attention. Thank you.